Pease Air Force Base was constructed in the mid-1950s as a strategic air command base during the Cold War with the Soviet Union. In the early 1990s, some 40 years later, times had changed, and the base was identified as one of many such bases to be closed across the country and around the globe. Working with the Base Realignment and Closure Commission, the airport and trade port was transferred to the state of New Hampshire. The state then established the Pease Development Authority, also known as the PDA, to manage and operate the airport as well as the trade port. Today, the Portsmouth International Airport at Pease operates as a joint use airport, meaning it has both civilian and military tenants. The airport has a dedicated commercial terminal building, which currently serves Allegiant Airlines and Atlas, who both have thrived there. The terminal has a dedicated port of entry customs facility as well. Other commercial tenants include PlaneSense, Gigunda, corporate jets, and turboprops, along with general aviation area for business and recreational aircraft. The airport is also home to the New Hampshire Air National Guard 157th Refueling Wing and new home to the Air Force's next generation refueling aircraft, the KC-46 Pegasus, which you can see about in the upper center of this photo. Pease is one of the largest runways in New England at 11,322 feet long and was an emergency landing area for the space shuttle at one point. The last major runway reconstruction was in the mid-1990s after the PDA had taken over. Now, in the 2010s, 20 years later, the asphalt pavement surface had shrunk, leaving fairly wide longitudinal joints that required constant sealing and maintenance. In addition, there was approximately 1,000 feet of concrete pavement on the south end of the runway that dated back to the 1950s when the base was originally constructed. This old concrete has a chemical defect known as alkali silica reaction, also known as ASR, that causes the concrete to swell and crack under its own pressure. In fact, the runway had been published as 11,321 feet long. When it was surveyed in 2018, the ASR swelling had lengthened the runway by 1 foot to 11,322 feet. By the late 2000s, it was clear to everyone it was time to reconstruct the runway. In this presentation, we'll discuss the major challenges of securing funding for the project, the logistics of the phasing of the reconstruction to allow the runway to remain open for the majority of the work, the challenges of COVID, the tactic of shutting down the runway for paving, and the opportunity for UNH students to learn real-world engineering challenges from the project. Here's a quick look at the project timeline. The planning process was instrumental in the success of all of this. It began around 2012, looking at the cost to shorten the runway versus maintaining the current length. Ironically, it was found to be more cost-effective and less expensive to maintain the current runway length. The next step was to determine funding sources to make the reconstruction possible. Typically, that would have been through an FAA grant, but as we'll talk about shortly, it was more complicated than that. By 2017, the funding sources were sorted out and design began. In 2019, the project started construction, and roughly a year later, in the fall of 2020, it was completed. In 2014, the FAA made it clear that they would only fund a runway reconstruction project to a length that was justified according to statutory requirements in their advisory circulars. Runway length is driven by demand and aircraft type, and the strict definition in the advisory circular meant only counting a particular aircraft type with 500 or more annual itinerant operations, such as Atlas, or 500 scheduled commercial service operations, such as Allegiant. Also, military aircraft could not be counted because FAA only funds civilian use. Pease has a diverse itinerant traffic mix, such as 767, 757, 747s, several other aircraft, but no single one met that 500 operations criteria. The current commercial service by Allegiant warranted a much shorter runway. After many discussions and meetings, the FAA issued their final decision in 2015. They would only support funding a 7,774-foot runway. That left the PDA to fund upwards of $7 million to reconstruct the rest of the runway. The New Hampshire Air National Guard had been based at Pease for many years. Their primary flying mission is to refuel aircraft in flight around the globe. The KC-135 aircraft has been the primary aerial refueling platform since decades, as a matter of fact, since the 1950s. With the aging platform, the Air Force had developed a new aircraft, the KC-46A Pegasus. Around 2014, the New Hampshire Air National Guard at Pease was chosen as the first joint base, meaning both civilian and military, in the country to receive the new KC-46 aircraft. By 2015, the National Guard Bureau had already invested much into the base and indicated they might fund the remainder of the runway reconstruction. There was talk about a 10,000-foot runway and a few other options, but in the end, they decided that the entire 11,322-foot runway was justified to support current and future missions. In 2017, they entered into what is known as a Military Construction Cooperative Agreement with the PDA. At this time, the New Hampshire Air National Guard and the PDA had committed to the funding source. So funding was agreed, but not quite agreed yet. The FAA and New Hampshire Air National Guard had some disagreements about who was paying for what items based on the runway length. For example, the New Hampshire Air National Guard contended the overruns at the ends of the runway were not associated with runway length. They would be there no matter how long the runway was, so they would not participate in funding those. That also applied to things like landing system upgrades and replacements and infrastructure not associated with runway length. FAA disagreed with some of this. Likewise, the New Hampshire Air National Guard was interested in replacing the 1,000-foot concrete ends of the runway, which is almost always more expensive than asphalt. FAA would not fund concrete, they'd only fund asphalt. In the end, though, the New Hampshire Air National Guard decided to accept asphalt based on lower construction costs. This was a challenging effort in that the New Hampshire Air National Guard and FAA did not agree on several items. The PDA and Hoyle Tanner had to moderate and facilitate many discussions to meet a very tight deadline for FAA grant application on May 1st of 2017. Challenging as it was, final agreements were made. Tenant coordination was a complex process, and conversations were completed years prior to the actual construction during the design phase. This included everyone, the air carriers, New Hampshire Air National Guard, PlaneSense, and all other users at the airport. The planning was done down to the week and then down to days when the construction schedule was worked out. It impacted everyone. In execution, I would describe it as an excellent partnership between the airport, Hoyle Tanner, Pike Industries, the FAA, the New Hampshire Air National Guard, and the airport users. All were committed to safety, the least impacts to aircraft use, and the best finished product. For a quick overview of phasing, the runway was shortened twice, as you can see here, once for each end for more complicated work on those ends without interruptions. Careful timing and planning of the shortened runway lengths was required for the airport users. Some aircraft were unable to use the airport during the shortened runway phases, and that needed to be planned and communicated well in advance. The subsequent phases were to complete the middle and overlaps into the ends and the two taxiways in the middle. Now, getting into a little bit more detail about construction, in 2019 there were two bidders, Pike Industries and Continental Paving, both proven qualified on large airport projects. Pike Industries won the bid. A portion of the project outside of the runway was completed in the fall of 2019, and we'll talk more about that in a moment. Construction on the runway started in April 2020, right after the COVID-19 lockdown. There was a lot of uncertainty because of the stay-at-home orders. At the same time, there was a sharp drop in air traffic, making the task easier. To give a picture of how things went, the typical contractor and airport work morning starts with safety huddles, large ring of people with masks staying apart, sanitation, masks, and even propane-heated hand-washing areas were provided. Construction workers were considered essential, and that led to a sense of commitment, and no doubt most on the job were happy to be working and doing it outside. Some contractors from outside New Hampshire came to work on the project. And surprisingly, no project halting supply chain issues impacted the project. It stayed on schedule. Due to the massive amount of paving, upwards of 90,000 tons, and strict quality control required by FAA airport pavements, Pike Industries proposed building an asphalt plant on the airport on a relatively unused area known as the North Ramp. This was expected, and it was well received since it reduced transport times and the ability to dial in the pavement mix quickly. This is ideal to maintain quality and speed for a project like this. It was not easy and took a lot of work for the airport, Pike Industries, and Hoyle Tanner to coordinate and make this happen, but everyone recognized the benefit. Not having to haul from a remote asphalt plant also saved enormous amounts of roadway wear and saved many thousands of gallons of diesel fuel. In fact, all of the phases benefited from the local batch plant. It enabled echelon paving, where staggered side-by-side paving machines and multiples eliminate cold longitudinal paving joints. These are the same joints that the airport had to maintain from 20 years ago. This also reduced the number of transverse joints, reducing future maintenance even more. Originally, the middle portion of the runway were planned to be done during the nights in a start-stop fashion, so the runway would remain open during the day. During the bidding process, it was suggested to shut the runway down completely for 2 weeks straight and pave around the clock. The strategy was actually well received by the airport and even the airport users, who all recognized the benefits of having uninterrupted paving operations, and also it led to a vastly superior finished product.
The volume of paving materials helps put the scope of this project in perspective. It included 104,500 tons of asphalt, 460 cubic yards of new Portland cement concrete, and 26. An existing 1,200 linear foot long open channel ditch had become filled with sediment and silt, resulting in a degraded man-made wetland area. The area was not properly conveying stormwater, causing a safety hazard on the airport with standing water attracting wildlife directly adjacent to the runway. Hoyle Tanner's stormwater design and environmental team collaborated on an innovative stormwater treatment system design that improves stormwater flow and reduces impacts to the existing emergent wetlands. The system was designed to be a closed culvert system with a soil filter for stormwater infiltration. The design includes 4 15-inch perforated pipes in a gravel bedding with 18 inches of soil filter media on top, installed over 1,200 linear feet, allowing for a continued open grassland environment. In addition to being more accessible and maintainable, this design element will improve hydraulic capacity and stormwater treatment of an adjacent 44-acre area. The newly maintained grasslands also enhance airfield safety by deterring large bird species from occupying the runway safety area. This project included the first FAA-funded high-intensity LED runway lighting system in New England. These lights were included as an additive alternate in the procurement process in anticipation of receiving FAA approval prior to award. This new lighting system involved the design of light fixtures and power distribution retrofits to accommodate the lower power loads, as well as coordination with the New Hampshire Air National Guard to reconcile the differing light signatures of an LED light source necessitated by military night vision goggle missions. In colder areas, there is a concern that the LED lights do not get hot enough to melt snow and would then need an internal heater that would negate any cost savings. But because the lights are mostly elevated above the snow levels for this airport, the Arctic kits were not needed. The few flush-mounted LED lights are within the traveled way, so they will be plowed to remove the snow. The resulting retrofit is anticipated to save the PDA approximately $15,500 per year in electricity. Over the anticipated 15-year life cycle, this alternative material design will ultimately save the airport approximately $243,500. The location of this project provided an opportunity to mentor the next generation of civil engineers. As part of a partnership with UNH's Senior Capstone Program, 5 students who selected this project were provided the project objective, CAD base files, and FAA design criteria. Throughout their senior year, our team worked with them and challenged these future engineers to complete a runway economic length analysis, airfield pavement design, geometry layout, and construction cost estimates. Throughout the project process, the students were introduced to design resources not traditionally integrated in the engineering curriculum, including learning how to use the FAA software Farfield to analyze the pavement design. These students also had an opportunity for a runway site visit during the data collection phase, so they could appreciate the tremendous scale of this 2.7 million square foot, 2-mile long runway. PDA's project goals were to secure funding to reconstruct the full 11,322-foot length of the existing runway and cause minimal disruption to the airport's operators during the project construction process. This project approach facilitated highly cooperative planning and design phases and an innovative construction phase that shortened the runway closure time while maintaining the facility operators' required takeoff and landing lengths. Runway 1634 was reopened on September 17, 2020, which was 30 days ahead of schedule and $2.8 million under budget.